Welcome everybody, thank you. I am Liam Corcoran. I'm with Scott McLean's lab. Some of you may have seen his talk. This is Megan, my colleague, and we'll be discussing American Woodcock as an umbrella species in the state of Rhode Island and why that relates to management. So the first thing that we'll introduce you to is the idea of forest succession. Those of you who are just in Dave King's talk will sort of remember what he discussed, and we'll go through just sort of how the forest matures. We start with an abandoned farmland. That's mostly how our early successional forest begins in Rhode Island, and it eventually matures into what we now have as red maple forests. We just go through these different stages. Again, they represent different forest types, and as the years go by, as the forest ages, it goes through each of these different processes. And so the forest type that we're focusing on today is early successional or young forest. And so that's characterized by this sort of shrubby habitat, open understory-ish, sparse trees, the like. Here's a map of Rhode Island, and what you'll see in green is the young forest throughout the state. What you might notice is that it is fairly sparse and patchy in the state, and that's characteristic of early successional forests because most of the time it's abandoned farmlands that age into early successional forest, or it's generated by some forest disturbances. And Dave King sort of talked about those forest disturbances. We'll talk about that in a second as well. Successional forest, it's pretty sparse in Rhode Island. It is approximately 3% of the total area in the state, and it is vastly declining in our region. This is mostly due to forest maturing. So, like we started with the abandoned forest, or the abandoned farmland, rather, as that ages, less farmland is available to mature into early successional forest, so then it all just ages out into mature forest. And that can lead to declines in the wildlife species that we know that depend on early successional forests. Some of those that were mentioned in the talk earlier. We'll go into why we manage lands in the first place, and that is due to these declines in natural forest disturbances such as wildfires, wind-blown events, snow, any sort of natural processes that open up these forest patches. They're declining historically due to mostly human disturbance, human activity that's stopping these processes, like forest fires, forest fire suppression, stuff like that. These are some examples of how we manage in Rhode Island, and what you might notice is it's sort of mimicking those natural processes. So that includes generated fires, clear cuts, selective cuts, just things to mimic natural disturbances, open up the forest either completely to create really large areas of early successional habitat, or just open up the forest canopy, allow things to grow in on the understory. Next, we'll lead into this umbrella species concept. Actually, conveniently, Charles Clarkson mentioned this morning. This concept of management for a single species can sort of be branched out and have indirect impacts, positive impacts on non-target species. The two examples we have here are sage grouse, as you can see pictured in this umbrella conveniently, and golden-winged warblers, which sage grouse are a grassland species, and golden-winged warblers are early successional forest species. In the context that we're talking about is American woodcock acting as this umbrella species in Rhode Island. Woodcock are a convenient umbrella species for two major reasons. The first being that they are an upland game bird, so there are a lot of federal funds available for management of this species, in particular to promote hunting opportunities. And that's where a lot of our conservation dollars come from, is hunting industry in the United States. The other reason is that they use a wide variety of habitat types for their different life histories strategies. And we'll get into that here. So you remember this graphic from shortly before. Woodcock use anything from abandoned farmland or open grasslands to the more shrubby or young forest habitat types for a variety of things. You may know woodcock do their singing displays in sort of open areas. That's what they use the abandoned farmlands or grasslands for. And then as we get into the more mature stuff, they use it for feeding, for cover, for nesting. So they operate in a wide range of habitats. Excuse me. And we can see that a bunch of different species also utilize these habitats. And not all of these individuals will go into all these different habitat types necessarily, and these are only just a small representation of what is available, or what individuals use those different habitats. But woodcock use all those different areas, and so do all these birds. So if we use woodcock, we get some federal funds for managing that species, and we can positively benefit all of these species, which are declining due to the declines in really successful forest habitat.
So now I'm going to talk a little bit about the past work that URI has done studying woodcock. So Roger Massey was one of the earlier students in Scott McWilliams' lab, and he tracked woodcock. He captured woodcock and then tracked woodcock with transmitters on them. And using that tracking data, he developed a predictive map of basically where woodcock like to be and where woodcock don't like to be. So when we look at the map on the right there, the red and orangey areas are high use by woodcock, and the blue and green areas are lower use or basically no use by woodcock. So based on Roger's tracking data, we found that woodcock really like riparian corridors, wetland forest, and upland young forest. Roger Massey also designated woodcock as an umbrella species based on these point counts that he did, which also David King just went over point counts. But Roger Massey did point counts for early successional songbirds in these areas. He did them in areas that would manage the woodcock and unmanaged random forest plots, and he found that there was a higher abundance of early successional species in these managed forest plots. And so RIDEM, which is the state agency that manages Rhode Island lands, uses Roger's predictive map to guide forest management. So basically they looked at Roger's map and they say, all right, these orange and red areas are where if we make a clear cut, then they'll have high use and create a lot of habitat for woodcock. And it also has the benefit for RIDEM that you're managing for multiple species, so it's very physically attractive as well. Another student that's been in our lab is Stephen Brenner, and he did a pretty cool experiment where he moved birds from these two different landscapes. So when we refer to, for the rest of the talk, we're going to be saying high and low likelihood of use or high and low quality habitat. And when we say that, it's always referring to how the woodcock see the habitat. So Steve moved birds, so that lighter gray on the left there, from low likelihood landscapes, so low use by woodcock, and he moved. Thanks again. Oh, okay. Oh well. So anyway, Steve moved birds from these low likelihood landscapes to these high likelihood landscapes. Thank you. So when he moved these birds from low to high quality habitat, the birds were far more likely to stay in that high quality habitat. But then when he moved birds from the high quality habitat, different birds, back to the low likelihood landscapes, the birds that he moved from high to low were far more likely to return to their original high quality landscape.
And so now we're going to talk about our research and how this fits into this idea of testing woodcock as an umbrella species. So our sites are sort of building off of this idea of site quality, which we were able to confirm with past research that woodcock can distinguish between high and low quality sites. So we have 6 sites here. Some of these areas you might know: Big River Management Area, Arcadia Management Area, Tillinghast Pond Management Area, Epley Preserve, which is an Audubon property, Great Swamp Management Area, and Francis Carter Preserve, which is a TNC collaborative site. And just a reminder that this idea of habitat quality that we'll be referring to, again, is based on this predictive map, which you can see the high and low predicted likelihood of use in the red and blue. And then again, confirmed by this experiment that moved birds, actually took birds and physically moved them to sites of high and low quality, and then see what the birds did. These are our 4 study species that we worked with. Obviously we used the American Woodcock, the species that we're focusing on as the umbrella species, eastern whippoorwill, eastern towhee, and prairie warbler. And just to give you a little bit of background, the American Woodcock, again, as I said, is an upland game bird. So it is hunted, and there are a lot of federal funds available for management of that species. They're sort of unique as they're an upland bird, but they're a shore bird. So as you can tell by their long bill there, that they are a shore bird, but they nest and they live in the forest. Kind of bizarre. A little fun fact that bill is prehensile, so when they dig in the soil for invertebrates that they eat, they can actually wiggle it around and open it up and move it all which way to get the food that they're after. You may know woodcock for their sky dances that they call them in the spring. The males, they go to these grasslands or abandoned farmlands, and they sit on the ground and they peep in a bunch of different directions, and then they take off and do this twirly little dance in the sky, trying to attract a female. And yeah, and they have been declining at about 1% each year for the past 50 years. So that's why they're also a species of interest for us in conservation. Another species that I'm working with is the eastern whippoorwill. Some of you may know the eastern whippoorwill as a nighttime bird that you may have heard its distinctive whippoorwill call where it gets its name. They are a nocturnal aerial insectivore, very understudied actually in our region and around the country really. So due to their nocturnal behavior. So we're very interested to see how they are utilizing habitats associated with woodcock as well.
All right, and then one of my study species is the eastern towhee. And whenever we're talking about our study species, we're talking about them when they're here breeding, so the orange area in the maps. So towhees are one of our largest sparrows, and you probably have seen them maybe in your backyards over the winter at the bird feeder. They'll eat seed during the winter, but during the summer they're omnivorous, and they'll eat berries, insects, anything that they can get. And they usually arrive to our area in late April and May, and then they typically depart. They breed, then they depart in September and October. And my other study species is the prairie warbler. So they winter in the Bahamas, the Caribbean, and southern Florida, and they'll migrate to our area also in late April, early May, and they depart on migration starting in the late summer. And since 1970, they've declined rather precipitously, like all early successional species. But the 2022 State of the Birds report reports that prairie warblers are a tipping point species that are predicted to lose 50% of their remaining population in the next 50 years, if nothing's done.
And all of these species are species of greatest conservation need in Rhode Island, in other states, but in particular to Rhode Island. So that's one of the reasons why we're interested in these species and studying their habits. Our objectives, so there's sort of 2 parts to this overall project. The first part is to determine how American woodcock and associated species move in low and high quality habitat. So I'm focusing on tracking these individuals. How are they physically moving in that habitat?
And then my portion is assessing territory size and the nesting success of both species, and comparing high and low quality habitats. So I'm focusing on nesting ecology.
We start off with some predictions about what we expect to see. In the high quality sites, we expect the birds to move less because they hypothetically have more resources available to them. What they're looking for is much more available, so they have to move less. So they don't have to fly every which way to get what they need, compared to the low quality sites where birds should move more in search of what they need because it may not really be there.
And in general, better quality habitat should have higher nesting success and be able to support more singing males versus low quality habitat. And I'm going to go into this more later. Liam's going to talk more about his project and then I'll talk. But just some rationale on why we're also focusing on nesting ecology. This is just another aspect of testing the umbrella species concept, and looking at breeding populations has important implications on how we manage species and how we manage habitat in the state. And this would be novel information on both these species nesting in Rhode Island.
So I want to talk about what I did this past field season, the 2022 field season, and that has to do with movement of birds. Just to remind you, my objective, determine how the birds are moving in high quality habitat compared to low quality habitat. These are my study species, woodcock and whippoorwills. These are the birds that I put transmitters on and tagged. What I first started out with was conducting singing surveys at all 6 of our sites. So just to remind you, 3 high quality habitat, 3 low quality. And we conducted singing surveys at all 6 of those sites to determine if we had adequate numbers of both woodcock and whippoorwills that we could then capture and put transmitters on and track their movements. So after I did that, after I determined that there were adequate numbers, I then had to track them. And so how do we do that? As you can see, we have these little, we call them radio transmitters. It's like a backpack with an antenna coming off of it. We put those on the birds. We first capture them and then put those on the birds. And those transmitters emit a signal that I can then pick up with an antenna and a receiver. So I have to go out and physically track these birds myself with an antenna and find out where they are. So I can go out, during the day, and they could be anywhere, and I have to crawl in and find them. And I don't know if this video is going to play. This is a whippoorwill with a transmitter taken off after I had put a transmitter on it. The captures took place at 2 of the sites, so this year was a little scaled back from the 6 sites that we have total. We have 2, 1 high quality site, which is Great Swamp Management Area, and 1 low quality site, which is Big River. And you'll notice these red squares. This is the area that I focused my capture efforts. So all the captures that took place occurred within those spots. As you can see, it encompasses grassland in both cases and some really successional shrubby areas on either side. Now, how did we capture them? You may have attended the talk from Manimate, but we use mist nets similar to them. They are these, it's exactly what it sounds like. It is a net, but it's up on these 2 big poles, and it stretches a long distance. And especially at night, the birds can't see them. And we use a speaker that plays the male call. So for woodcock, we would play a peent. For whippoorwills, we play their whippoorwill call. And the actual birds, the male birds, they sort of get agitated, or they're like, who's in my area? And they come in and they try to be aggressive or check them out, and then they fly into a net, and that's how we get them. Alternatively, for the females, it's slightly different. They don't always come into those male calls. So we actually have to go out, and this year we used a thermal imaging camera. And this is basically what I saw. I would go out at night with this camera and just look around in the fields, and I would see this little white blob that I guess kind of looked like a woodcock, and then I would take a big light, a spotlight, shine it on what I thought was a bird. If it was, then I used a big hand net to go down on the bird and catch it. So we ended up catching 12 woodcocks, 6 at either site, some mix of males and females, and we caught 14 whippoorwills. So that was 12 adults, 6 at each site, in addition to 3 fledglings that I was able to capture that were actually fledglings from 2 nests that I was able to find during my capture. And this was the result. So just to remind you, this red square is where I ended up capturing both all the individuals. And this is the result of the tracking all summer long. These polygons that you see, these sort of shapes, are where each bird that I put a transmitter on spent its time. Woodcock are on the left, whippoorwills on the right. You'll notice right away that the woodcock shapes are much larger than the whippoorwill shapes, which gives pretty good evidence why woodcock might be considered an umbrella species and why management for them might be beneficial. The whippoorwill shapes really are localized right around where I captured them, sort of along the edges. And we'll notice the same trend at Great Swamp, which is our high quality site. The woodcock shapes, really big, spreading over a large area. The whippoorwills really hanging around just that immediate area where I captured them. So interesting observation. So this is different than what I sort of set out to. So the maps that you just saw were the result of me tracking. Still, that's just preliminary results. Still sort of doing statistical analysis on other aspects, but that's really the end game of what I did this past summer. Some other things, so the woodcock, we've been tracking them for the past 10 years. They've really acted exactly as how we expected them, so nothing really interesting there. But whippoorwills, this is the first time we've done anything with whippoorwills in the state, so tracking them is pretty unique. We found that, I found that the males, once you put a transmitter on them and once they had a mate and a nest, I could track them at night, and then the males would then go to the nest, take a turn brooding the chicks, so sitting on top of the chicks, while the female went off and got some food for herself. Also the whippoorwills, they also prefer, I found, they like edges a lot. So edges of forest near fields, even edges within the forest. So if you think of a big mature forest stand, go back to this map here. So if you think of sort of an area like this, there's not really an edge there, but there's trails within that forest, and they like being near the trails too. So that acts kind of as an edge. And you can imagine that those trails might be a corridor for prey items that they might want to be found. 2023, we're going to do something a little different than what we did this year. So this year, I'll just reiterate, we did this radio tracking. It's called VHF tracking. You may have noticed that if I have to go out and do it myself, it takes a lot of effort to then track those birds. At max, we can get a single location per day if I go out and do it myself, because I'm spending a lot of time driving between sites, crawling through a lot of shrub stuff, the like. But we're going to employ an automated telemetry system this coming season. So this is, as it sounds, automated. It's a system that sits out in the area that you're interested in. You set up this equipment, and once you put transmitters on these birds, the transmitters emit a signal, and the equipment's already out there. So it's collecting data 24/7. It's always out there. It's a really unique sort of system that we're going to be using this going through. Here's just a quick overview of how that kind of works. So this is a tag. This is the receiver that sits out in the field. They're not that big, pretty easy to put out there. So the tag emits a signal. It's picked up by a bunch of these receivers all at once, and you can sort of triangulate it kind of like a cell phone tower. And then once they collect their data, they send it to a main tower, and that's how I receive the data. That's how I can then look at where these birds are spending their time. This is an example of what an array, as we call them, an array would look like at Great Swamp. So each of these red dots, it represents a receiver. And so we look here. Here is the home ranges, as we call them, of the whippoorwills, overlaid onto where the nodes might be, the receivers might be. And as you can see, we get pretty good information about how these birds are moving. The advantage of this is that basically every time the transmitter emits a signal, we could get a location. So if it's emitting a signal every 15 seconds, multiply that by all day, multiply that by all week for a couple months, that you're getting really pretty good data on how these birds are moving. Now Megan will talk about it.
So now I'm going to talk a little bit about my project. So I'm going to talk about eastern towhee and prairie warbler nest ecology. And just a reminder, my objective is to assess the territory size and nesting success of both eastern towhees and prairie warblers in the state at high and low quality sites as woodcock state high and low quality sites. So some of my predictions for these two breeding songbirds are that higher quality sites should have higher density of territorial males, and those males should have smaller territories as compared to low quality sites. And they should also have a greater density of nests. The phenology of the nests would occur earlier, and those nests should fledge more young. So as a reminder, these are my two study species, eastern towhee and prairie warbler. They both have heavy early successional habitat use and have declined with habitat loss, which is the maturing of forests in our state. And they both differ in their foraging patterns, their migration habits, and their nest locations. So I've got a couple of project components. I'm going to go through all these really quick. So I looked at the density of singing males this year, the territory sizes of singing males, nest success, fledgling success, the hatch date phenology of nests that I found. I looked at provisioning rates, and I also looked at predation on the nests that I found. So these are just some of the measures that I will be going through. So one of the first components of my projects was density and territory mapping of singing males, and that included doing point counts, territory mapping, and targeted mist netting of singing males. So David King went over this a little bit already, but a point count is just is a census technique commonly used in the bird world, where you go out to either a specified area or you walk on a transect and you do a timed count and just assess how many birds you see or hear in the area. So I use this to get a number of how many prairie warblers and eastern towhees were singing at my sites. So I did that on a rotating basis at each site, and I started around April 25th, and then I ended those surveys around July 15th when everyone was mostly done singing and they were nesting and busy with their babies. And the peak of singing for most of the sites was somewhere between May 1st and June 1st. And I also surveyed a set area. It was our projected CTT grid area that was between 20 and 35 hectares. So using those numbers of how many singing males I had at each site and also the CTT grid area, I looked at the density of singing males for each site. And in general, so on the left we've got eastern towhee there, so I had high numbers of and also blue is low quality for the site and green is high quality. So Francis Carter is one of our low quality sites, and it had similar numbers of singing male towhees as Tillinghast did. So there's something interesting going on there with how woodcock perceive high quality habitat versus how eastern towhees perceive high quality habitat maybe. And then for prairie warblers, the highest counts were also at Francis Carter and Tillinghast, and we did not record any singing male prairie warblers at the Great Swamp. So these are preliminary results, so this is right now, it's just showing the average density at each site. I'm not sure if there's any significance as this relates to my study. The next thing that I did was territory mapping. So this map on the left is an example of using playback to map ovenbird territories. So this person, they go out in the fields and you put a speaker out with playback and you record with like a GPS point or a hair neuron map the singing males closest approach the speaker, and that's just the territory that's defending. So Liam mentioned home ranges, and we define that loosely as anywhere that a bird wanders within its habitat, but a territory is a little bit more specific to that bird, and it's where the bird is defending an area. So how did I do this? I territory mapped singing males by catching the birds. I put out mist nets to catch the birds, as Liam explained, and using some playback. So that's me in the upper right extracting a bird from a mist net, and then we put a color band on them and assign them a color code, and they also get a federal band. And it was important that I would get males that were going to be breeding in the area, just because of sometimes males would leave, they were still migrating, so I only tried to capture males that were seen for 6+ days. And again, I used an audio lure to capture them and band them with color bands and the silver band. And then mapping territories generally took about 15 to 30 minutes depending on the vegetation. Sometimes it was really thick. I don't know if you guys have been to the early successional cut of the Great Swamp, but that one took a while to map birds in. And some of our results from that are across the 6 sites, I mapped 54 towhee territories and 40 prairie warbler territories. So prairie warbler territories are a little bit low because there was no males at the Great Swamp in our grid array. And then there's an example, Liam just talked about polygons, so I made something similar based on the points that I took at the territories to make these territory maps. So prairie warblers are in that light blue color, and then the pink is towhee territories. I also have some nests on there that we can ignore for right now. And that's at one of the Audubon properties. So I'm just gonna go over this really quickly. But in general, for towhees in the green at the top left there, at the high quality sites, towhees had pretty similar territory sizes, whereas for towhees in the bottom left and the low quality sites, at Arcadia and Big River, their territories were rather much larger than they were at Francis Carter. So there's some sort of habitat level or site level effect going on at Francis Carter where they have slightly smaller territories, which if you remember from my predictions, higher quality sites should have more males with smaller territories. So that could be some sort of site level effect that's having Francis Carter act as more of a high quality site for towhees. And then for prairie warblers, they were kind of all over the map for high quality sites on the top right there. Again, no singing males at Great Swamp, but Tillinghast, they're about 0.69 hectares, and at Epley, they were 1.22. So there's a little bit of a range there, and I'm not really sure why. And then in the bottom right, Arcadia and Francis Carter, again, had similar territory sizes, whereas Big River was very large for prairie warblers. And so this is a comparison of Tillinghast Pond Management Area, which is one of our high quality sites, and Big River Management Area, which is one of our low quality sites. And this is just showing the average, the territory size of these birds. So again, you can see these maps are at the same scale. So you can see that there's some kind of site difference that's perhaps being influenced by vegetation types. So Tillinghast is far more vegetated than Big River. You can see on the map that there's, if you've been there's a bunch of sand dunes, and there's not a lot of understory for these birds either. So that could go along with how the birds are seeing the habitat and assessing it and how big their territories are. So now we can look at some baby birds while I grab some water really quick. So there's a little fledgling eastern towhee in the bush there. But the second aspect of my project was looking at nest success, fledgling success, hatch dates, provisioning rates, and predation. So this is an example of a towhee nest on the lower left there, and then prairie warbler nests on the right. So these birds both have open cup nests. Towhees will generally nest on the ground or up in a shrub, or 7 feet up in a tree. They're pretty variable. And prairie warblers are a little bit more general in where they nest, more similar. They usually nest about 1 to 1.5 meters in a thickly vegetated shrub, and their nests are very concealed and hard to find. So nest searching. I did nest searching from May 10th to August 15th, and what I did was I looked for females or males building nests, carrying food to nestlings, or sometimes birds will remove fecal sac from young birds in the nest. Occasionally, when we were territory mapping, we would actually step over a towhee nest and scare her off the nest, so that was another way that we found nests. And for any territories that we couldn't locate a nest in, we then did a fledgling survey, which is where we just looked for males or females provisioning young. So this is just a graph showing the average nest fate of all the nests that I found. Over the course of the season, I found 28 towhee nests. In general, the predation level is to be expected for these songbirds. It might seem a little bit high, but songbirds are predated pretty heavily in the bird world. So on average, their success and their predation rate were almost the same. And again, this is preliminary results, so I'm not really sure if it's a factor of site quality yet. And when I say successful nest, that's a nest that had at least one bird leave successfully and fledge. A predated nest was a nest that was predated in the egg stage or as nestlings, and an abandoned nest was a nest that was built and never laid eggs in. So prairie warblers have a different scope on the graph there. Their predated nests were a little bit higher, especially in high quality habitat. So there could be something happening where good quality habitat for prairie warblers is also good quality predator habitat, or whatever suite of predators is acting on prairie warblers. And their abandoned stats are a little bit higher. That's because prairie warblers do this interesting thing where they'll build a nest fragment and the female might lay one egg in it and then she'll abandon it entirely. And that happened a few times, but that's just part of their life history. In total, I found 15 prairie warbler nests throughout the season. So some examples of predation that I observed were red squirrels, snakes, and blue jays. So in the larger picture on the left there, that's a red squirrel actually. on a towhee nest, and if you can see the little brown shape that's a little bit closer, that's the female trying to get him to stop, but that didn't happen. And commonly, that was what I would find when I found a predated nest, was just an egg or two left that had been cracked open. But again, it happens. It's rather high for songbirds. So another thing that I looked at was the date the nest hatched. And you can see, in general, for towhees at high-quality sites, a lot of the nests hatched in the beginning of June, and later, they hatched later in low-quality sites around early July. So that could be a factor that's affecting their resource gathering at these sites. High-quality habitat might have more resources that's allowing them to reach this nesting stage sooner than a low-quality habitats. Then for prairie warblers, it's sort of all over the map, and in general, at high and low-quality habitats, June 20th was their average nesting date. And again, these are just preliminary results, and we'll see what happens this upcoming field season. And these are just two nestlings. So towhees on the left and prairie warblers on the right. So the young are altricial, which means that they require high parental care. But the other side of that is that they usually leave the nest within about 10 days of hatching. But an important aspect of being altricial is that your parents need to care for you a lot. So another aspect of my project is looking at provisioning rates, which is how often the mom or dad come back with a food item and provision the young. So it's a little towhee chick that's begging at me after I went to check that he was still there. And then there's a female on the right there that's providing some tasty green caterpillars to a nest that's right underneath that log. So both male and female provision for both species, and it's possible that I think that high quality habitat means more resources for these young. So in general, these nests should fledge more young, and that the young should be in better condition when they fledge, and hopefully that survival carries over. But the big question is woodcock high quality habitat the same could be songbird species? So I tried to assess provisioning rates for several nests by looking at differences in foraging trips, food type, and availability. So I used trail cameras at these nests to see the timing in between provisioning trips, but there's a lot of problems with this because it meant finding nests before they hatch, and nests are easiest to find when mom and dad are making a lot of trips to the nest, which is way after I want to find the nest. So it also depended on the nest surviving to fledge, and again, songbirds had pretty high predation rates on their nests. And the nest areas being camera trappable was rather difficult. Towhees nest in the ground, and prairie warblers nest in some very dense shrubs that usually can't support a trail camera. So I'm working on solving that problem this winter.